Hello everyone, I'm a tutor with UPlads and today we are going to continue our training in SQL. In the previous lecture, we encountered some AND logic or logic. We queried a lot on our database using select clause. We filtered our data using the where clause. Today we are going to continue with some more clauses, and to start with, we are going to have a look at the update command. So let us try to first select the table. So we had made some records in uplats.users table. So I have 5 records here. Now let's say I want to update row number 3, that is the record with ID equal to 3. I want to modify its age from null to, let's say, 100 or whatever value. So I will be using update command here. Now what happens in update is that it is basically used to modify the existing records in a table. So I will write something like this. I'll update the table that I want to update. So it is uplads.users. I will set my age to, let's say, 100, where ID is equal to 3. So now what this will do is it will update the table of uplads.users. Then we have to give the parameter where we are setting the age, where the modification is required. So I'll set my age column to 100 or whatever value you wish to set. And this is the filter condition, that should this value age equal to 100 be set for one particular record or for all the records. So when I run this, update is made. Let us try to see if our update is successful. Yes, it is. So as you can see, before update, my ID 3 had age equal to null. And after update, my ID has age 3 equal to 100. So that means I've successfully updated my record. And as you remember, that update statement falls under the DML command. That means we have manipulated the data. It was null before, we have manipulated it and we have made it 100 ourselves. So that's why it is a DML command. Now let's try to try some more examples with it. Let's say this time I want to update the name column. So I will again use update uplads.users, set name equal to, let's say you want to change the name to uplads. For record number 3 again, so I will put where ID equal to 3 and my row is changed. So as you can see, for row number 3, it was PQR initially, and now it is uplats. So that means we have again successfully manipulated our data. So that was update for you. Now, what happens when you are not specifying any condition? Let us try to understand that as well. Let's say if I write something like this, I update the users table and I set the age column to 100, but here I have not given any condition. So when I execute, you can see that the rows that is not equal to 100 have been affected. Now when I try to select this, or if you can see, my age column has only one value, one distinct value, that is 100. Because I did not specify any condition here, and that is the reason MySQL thought that we have to update it for all the records. So you have to be very careful what kind of command you are giving to your database. It should be very clear. If you want to update just a single statement, you should use the where command. If you want to update the entire column as such, you should mention that as well. So you have to be very careful while executing update and delete command. Now, moving on to some aggregation functions. Now, what are aggregations? Aggregations are those columns where you're trying to gain some information out of that data. That means if you want to find out some count, if you want to find the min value of that table of one particular column, or max value or average of a particular column, all those fall under the aggregation command. So let us try to execute few. To start with, I will start with min and max command. So the min function, as the name says, returns the smallest value of the selected column from the table. The max function returns the largest value of the selected column. So what we'll try to do is we have another table with us from uplads.persons. Let us first view this column and then try to play around with this data. Now what I want to do is I want to find out the min and max of age column. So what I will do is I'll find out the min of age comma max of age from. I can also use two aggregations in one SQL command, just the way I have written it. So now what will happen is I will get two columns in my output, one with min column and the other one with max column. And as I had told you that we need to give some alias to it just so that it is in a the output is in a readable format. So max age, let's say from our table uplads.persons. What I get here is, if you can see from data, the min value obviously that is visible is 20, max value is 100. Now these aggregations don't count the null values. So even if this is null, you might think that this is the lowest value. But as I had mentioned so many times before, that null does not mean zero, or null does not depict a particular value. Null is just the value that we don't know. So since we don't know the value of this null, we cannot use it in our functions. So when I select min age and max age, the records which are having null value in it are avoided. So I get minimum value as 20 here and I get 100 as the maximum value. Now moving on to the next one, you might be thinking that why did I take age here? Why did not I try with the varchar columns here? So as you can see, last name and first name are some varchar values. And what if I perform min and max on it? Let us try to do that. If I perform a min function on, let's say, last name column, and let's say a max on last name column, again from the same table persons. So what is happening here is, here's you will see. Now let us try to analyze ourselves. uplads.persons min last name is ABC and max last name is yellow. Now very well you can see the logic behind this. What MySQL has done is, minimum of a varchar value is the alphabetically ascending order. So ABC, A is the first letter if you sort it alphabetically. So my min value is calculated against that. So my min of last name will fetch the value starting with A. And as said earlier, max will retrieve the particular column, particular data, which has the which comes last in the ascending order of an alphabetical sorting. So as you can see in the data, Y is the maximum alphabet that we get when we sort it alphabetically. So ABC will become my minimum of last name and yellow will become my maximum last name. Now this holds true with MySQL. But when you are executing it on some other platform, they might not be evaluating it the same way. So it's better that you first check the syntax for the other platforms. Does it work the same way we had seen in MySQL? Then good, you can go ahead with it. But it is mostly recommended not to use aggregation functions on varchar values, as the working behind the system in the database system will not be the same everywhere. So it is recommended not to use min and max functions or any of the aggregation functions on varchar columns. Now let us try to support our assumption. We will put first name here. And before executing, let us try to understand what output we should get. And if we get the same output, then we have actually assumed it right. So if I take min and max of first name, as you can see here, courses is the minimum value if we order it alphabetically. And XYZ seems to be the maximum value if we order it alphabetically. So my min of first name should fetch me courses and max of first name should fetch me XYZ. Let us see, what do we get? Yes, our assumption is right. Min of first name has given me courses. Max of first name has given me XYZ. So that is the basic assumption with min and max, but it is recommended not to use with with varchar values. Now, there is another interesting thing that I have already told you, that max and min or any of the aggregation values do not work with null values. It will return null when there is no row to select. For example, for character columns, max finds the highest value in the collating sequence, and max is a deterministic function when used without the over and order by clause. Over and order by we will understand a little later in this course. But for now, this seems to be a very valid expression. So if I try to execute something like this, max of a null, let's say, so I will have some randomly thrown values, which are actually not correct. It will not give us any value. It does not depict anything. So it is, again, you have to be careful with your aggregation functions. Moving to next, we have our three main functions that you would be using most of the time when you are dealing with some analytics data. We have count, we have average, and we have sum. To start with count, so I'll write down basic query first to see the raw data, and then we will perform our aggregations. So I have select star from uplads.persons. What I'll do is I'll select count star, comma, count one from uplads.persons. Now we will get the same number of rows for it. Count star basically gives me number of records in that table. Count one, what it does is it will take the first column of that table and it will take a count of it. Mind you, it is not a distinct count. It is basically giving the number of records. So had that been the case, that 2 is repeated twice in this table, then both the rows will be counted here. Had it been count of distinct way column name, then it would have been that it is just retrieving one row out of those two duplicate values. So let us see the output we get is 6 rows, and as we can see there are 6 rows in this set. We also retrieve 6 rows from the table using count star and count one. Now, as I already told you that what is the difference between count star and count one. So this is the most common argument, that count one is the assertion that count one is faster than count star. But according to a theory, count star takes all the columns to count the rows, and count one uses just the first column. Count one uses the first column of the table. So it will give me only the count of these many records. And hence we could say that if my count one is retrieving, working on only one column, it would be the fastest to work. While count star, since it is retrieving all the columns and taking the record for it, then probably it might be a little slower. The argument is still in place. If you try to search for it, you will find n number of articles which you can go through. And in count one, it is generally assumed that the first column is your primary key. So count one, when you are taking, basically it is referring to the first column of the table, which is assumed to be the primary key of that table. So that is the main difference between count star and count one. Now let us try to play around with this data. Now there is one more possibility which can happen. Let's say instead of count one, I have specified count of some column, let's say age column. Now you would expect that in this we will get all the three outputs to be 6. But what happens is we are getting count of age to be 4. That means, just the way I told you for min and max, whenever you are dealing with aggregations and you are specifying some column name, it will neglect the null records. So since I took count of age, there were 2 null records out of 6. So I got the output to be 4 here. So you have to be careful that if you are giving one column name to your data, then there should be no null values in it. Going back to our collace, which we had tried long back. Let us try to deal with it. That how can we overcome this age part? It should also fetch me the same data as count star and count one. What I'll simply do is I'll use collace. So I'm sorry with the spelling. I hope that's the right one. I'll give that column name. I'll give a dummy value here. Let it be 0 or let it be 100 from uplads.persons. So here what will happen is it will now give me the record to be 6. Now my output will be 6. Why so? Because now my null values are replaced with a value, and hence when I take account of it, I get the same number of rows I have as I got with count star and count one. So be very careful when you are using aggregation functions and you are giving one of the column names as your parameter, as you have very clearly seen that the null values are neglected while taking the count. Moving to our next, average. Let us try to take average of, first of all, let me select the raw table so that it is very clearly visible to you guys. Let's say I want to take average of age that is present in my table. I want to find out that what is the average age I have in my table. So my basic query would look like this. We use AVG for average. I will pass the column name from uplads.persons. I get the output to be 42.5. Now how did we come to this value? Select 30 plus 20 plus 20 plus 100 divided by, now when I told you that aggregations do not take null values into the consideration, so does average. So even average does not include these null records. So here I cannot take 6. If I take 6, it will not give me the correct average which I thought of. It will give me 28.33. So what I will do here instead is I will have to take 4 because there are only 4 not null records in my table. So when I do this, I get 42.50, which matches exactly with the average function. So you might have not now understood that how these aggregate function works when there are null columns in the table. That's why in my first most lecture, I had stressed upon this area that the null values are very important to handle and the way you look at data. Because if you had taken 6 here, thinking that these are the number of records present in your table, your average would have been 28.3. That means you are targeting, let's say, some age group of 28. But according to my average function, I'm getting 42.5. That means I'm targeting age group of 42 or 43 maybe. So that is not the correct way of finding out average. That is why you have to be very careful while dealing with null values. Next, let us try to simplify some things for us. Let us try to again see the data we have with us. Dot persons. Let's say I want to find the average of ID, though this is not making any sense, but we'll try to find average of ID. I pass on the ID column from uplads.persons and I get output as 4.1667. Now, as you can see, let us try to evaluate it ourselves. Select 1 plus, 1 plus, 2 plus, 3 plus, 4 plus, 5 plus, and 10, and divide it by 6 because we had 6 not null values. My answer exactly matches with my average function output. So that is it about average. Now moving on to sum. Again, let us try to see our data, raw data. And now let us do one thing. We'll try to take the sum of age column here. The basic calculation would look something like this: 30 plus 20 plus 20 plus 100. And since null has no value, we'll not consider that. We get 170. Now let us do one thing. We'll take the sum ourselves of the age column from uplads.persons. So you get 170. That means we have exactly done the same. We have understood the calculation behind this sum function that has been set. Now, moving on to the next interesting topic, that is group by. Group by is very important to understand. Now, whatever aggregations you did till now were based on the overall aggregation of the table. But let's say I want to aggregate it at a certain level. Let's say that if I want to aggregate it at some last name level or something of that sort. Now, since our table is not in that format, we have not inserted much rows to explain your group by with that depth. So here I will be using the table, country code table, country language table to prove the data point, to prove the group by function, how it works and the internal working of it. So let us try to do that. Now basically what group by does is that this statement groups rows that have the same values into the summary rows, like find the number of customers in each country. All this all this comes into the group by comes into the scenario when you are trying to group it by as per another attribute in the table. Now the group by statement, this is often used with aggregate functions like count, max, min, sum, average to group the result set by one or more columns. Let us try to find it out. Now I have this table with me, country language from the um, schema world dot country language, and let me limit it for you because you have seen how the results are. Okay, so what has happened now is I have selected country code, and according to that country code we have taken count of distinct languages from this table. Now what does this data mean? ABW country code has 4 different languages. AFG has 5 different languages. AGO has 9 different languages. Now let us try to see in our table how does this look like. So if I do a select star from our world.country language table, where let's say my country code is equal to, oh, I am so sorry, select star from world.country language, where my country code is equal to ABW into quotes because this is a string value, this is a character. I should get 4 records here because we can see that there are 4 distinct languages that are being spoken in country ABW. So let us try to execute. As I can see that for ABW we have 4 different languages available in this table. So you must have understood that. And had it been something like this, let's say I do not group it by country code. I simply take a count of distinct languages. So I get 457 records. What does it say? That I have 457 different distinct languages in this table. Now I can also find out something like which is that language which is spoken in most of the countries, which has more than one country, which is used in more than one country. So let me write down the code for it. Language, comma, count of distinct country code from world.country language. And now I'll group it by language. I'll put a limit to it, 10, because we have a lot of records here. And as you can see, the Afrikaans is used in 2 different countries. There's a language spoken in 2 different countries. Albania, it is spoken in 4 different countries. So this has helped me fetch that which language is used in different countries, while this query has helped me understand that one country possesses how many different languages. So you should be able to read this query by now. And using the query itself, you should know that what output is expected from this query. So that was group by for you. Now there are few interesting facts that how the group by thing can go wrong. Now let's say there is one column. Let me first display the raw table to you. Not you plaids, we are dealing with world dot country language now. Limit it by 10, let's say. So as you can see, there are some values of T and F in is official. Is official means yes, true, it is official. F means it is an unofficial language, maybe something of that sort. We don't know what it means. But what we can do is, let's say I want to find out the group by country code and is official, the count of languages. So I'll come to know that in that country how many official languages are present, and in that country how many unofficial languages are present. So let's say I decide to write a query something like this: select country code, comma, is official, comma, count of distinct language from my world.country language table. And now I just group it up for one column, let's say for just one record, let's say ABW. So I use country code equal to ABW, and now I group it by just country code. I don't group it up by is official. So I will get something like this. Okay, I got country code ABW. I got 4 languages which is grouped by just ABW. This definitely does not mean that there are 4 languages which are official in ABW. This is a very wrong data that we have interpreted. And why did that happen was because we did not mention is official in our group by clause. So it has taken account of distinct languages as per my group by column country code. And so we can see this incorrect data. But if I go and check that in my country language table, where country code is equal to ABW, I get 4 records. With T, that is official, there is Dutch is the only official language in ABW. While here I can see that it displayed 4 different languages under official language, which is not correct. So we will try to rectify that. Moving to the query. We will group it by both country code and is official. Now I'll get 2 records saying that with is official D, I have 1 record, and with is official F in ABW, I have 3 records as seen in this data as well. So again, whenever you are using group by, you have to make sure that you are grouping it by that all the columns that are mentioned. Otherwise, the display that you are doing of the data might not be correct. The view that you are trying to present might not be correct, or the interpretation might not be correct. So that was group by for you. Now let us try to play around with this group by. We'll try to find out some more data. Okay, that was because of the quote again. AFG. Okay. Sorry, I'm not using the schema. Okay, schema name dot table name. So as you can see that in world.country language table for country code AFG, I have 2 official, I have 3 official languages. I'm sorry, we have 2 official languages, that is Dari and Pashto. I'm sorry if I'm not pronouncing it correctly. And we have 3 unofficial languages, that is Uzbek, Turkmenian, and Balochi. So we have 3 records for unofficial languages and we have 2 official records. So let us try to sum it up using our group by data. So what we'll do is we'll use country code, we'll use is official, and we will take the count of distinct language that is being spoken in our table, and from world.country language we will first of all filter our data because we are only checking for one country code that is equal to AFG, and we are grouping it by, let's say I don't want to write the entire names. I'll just replace it with 1 comma 2, which shows that 1 is country code, 2 is official as per the order of select. So when I execute this, you can see that for official languages of AFG, I got 2 records, which is true as per our raw data. And for unofficial language, we got 3 records, which is again holding true as per our raw data. So that was group by for you. Next, along with group by, we have having clause. Now this having clause was added to SQL because the where keyword could not be used with aggregate functions. What does that mean? Let's say from world.country language, I want to find countries which speak more than one language. Okay, so something like this. It would look something like this. Country code dot count of distinct language from world dot country language group by country code having more than one language. So what I'll do is having count of distinct language greater than 1. Let me limit this for you. So here you can see that I have retrieved only those country codes which has more than one language spoken in their country. Let us go and check it in our table, or in our raw table, that is world.country language, for country code equal to AND. Yes, I have 4 different languages being spoken in country code AND, and that is what we have retrieved here. So this having condition basically works on my aggregated data. And let's say using the same query, we'll try to find out the countries which have distinctly one language being spoken. So as you can see, I have retrieved 5 records because I've limited it to 5. I have some records and only one language is being spoken in that country. So let me try to select it from world.country language, where my country code is equal to, let's say, CYM. I have only one record, that is English. Only English is being spoken in that country, CYM, and it is official. So our assumption was correct here. How does, I hope this is very clear to you, how does having work? Now this can also work for more than one group by columns, as in if I want to find out for official language, if there is only one official language, I can have that as well. Let us try to demonstrate that. Select country code. Let's say I have 2 conditions on my aggregation. Distinct, let's say, is official, and if I take count of distinct language from my world dot country language, I am grouping it by country code, and my having condition has 2 conditions in it, and having clause has 2 conditions in it. One is distinct is official should be equal to 1, and let's say there should be more than one official languages, but I want only those countries which has only only official languages spoken in their country. So something like this, distinct language is greater than 1. Let me limit this data for you with 4. If you can see that in AGO, there are 9 official languages and there are no unofficial languages spoken in the country. Let us try to see that in our raw table to make you understand better. Where we'll check the records for BFA. So country code equal to BFA. As you can see that there is only there are only unofficial languages spoken in BFA because S official is equal to F. And we have 6 different languages in it. That's why the count 6 here. So here we retrieved one, but we weren't sure if we are retrieving the official language or we are retrieving the unofficial language. So if you want to specify that, you can specify that as well in your where clause here. So that was having clause for you. And we will conclude our today's session with having. We will continue with more clauses in our next lecture. For now, let me print a bye-bye message for you. Since we are dealing with SQL, we should be welcoming you and sending a bye-bye message to you over SQLs only. Thank you from you, Plats. I hope this message was, I hope this lecture was very helpful to you. It's mandatory that you deal with null values very carefully because that's the most tricky part in SQL, handling null values. And this can come into the picture when you're dealing with aggregations. We're selecting few columns. When you're taking aggregation over the Excel file, that value might not be the same as you are taking aggregation or as you're taking the average value over SQL, and that is because of null handleability. So you have to handle null in a very good way. And that's how we'll conclude our today's lecture. We'll continue with more clauses in our next video. Bye-bye, and thank you from you, Plats.